Welcome back to Fullstack Infrawatch. In our previous lesson, we laid the groundwork for understanding basic task queues. Today, we're taking a significant leap forward, moving beyond simple queues to build production-ready task orchestration systems. This isn't just about running tasks. It's about orchestrating complex workflows with precision, resilience, and intelligence, much like Netflix processes its content or Spotify manages playlist updates. By the end of this lesson, you will be equipped with the knowledge to design and implement sophisticated task engines. Specifically, you will understand the core principles of workflow orchestration and how to manage task dependencies effectively. You'll learn to implement conditional execution, allowing your tasks to make smart runtime decisions, and integrate event-driven callbacks for seamless system integration. Crucially, we'll dive into how to design robust error recovery strategies that make your systems resilient to failures. Finally, you'll see how to integrate task orchestration with broader infrastructure management, turning your basic task queue into an enterprise-grade platform. Ready to transform your task systems? Let's begin. At the heart of any sophisticated task orchestration engine lies the concept of a dependency graph. Think about it. Real-world systems rarely execute tasks in isolation. An e-commerce order workflow, for instance, involves payment, then inventory reservation, then shipping, and parallel notifications. We model these relationships using what's called a directed acyclic graph, or DAG. Each node in the DAG represents a task, and the directed edges represent dependencies. This structure ensures that tasks only run when all their prerequisites are met, and, crucially, prevents infinite loops. Our orchestration engine uses topological sorting to determine the correct execution order. This algorithm helps us validate the workflow definition for cycles and ensures logical consistency before anything even starts. During execution, the system performs real-time dependency resolution. It continuously evaluates which tasks are ready to run because all their upstream dependencies have successfully completed. As soon as a payment task finishes, for example, it signals to the inventory reservation task that its turn has come. This dynamic approach allows for efficient, parallel execution wherever possible, maximizing resource utilization. Understanding DAGs is fundamental to building any robust workflow system. Beyond just dependencies, production workflows demand runtime intelligence. This is where conditional execution comes in. Imagine a content moderation system. You wouldn't want every piece of content to go through manual review. Only borderline cases need human attention. Our conditional system evaluates task contexts using predicate functions. These are simple functions that return true or false, determining whether a task should execute. Conditions can check previous task results, current system state, or even external factors like the time of day. This prevents unnecessary work and optimizes resource usage, making your workflows much more efficient. Next, let's talk about callbacks and hooks, the backbone of event-driven integration. Modern systems thrive on events, not constant polling. Our callback system provides critical hooks at every stage of a task's lifecycle. You can define onStart to initialize resources or send notifications, onSuccess to trigger downstream systems or update metrics, onFailure to alert operations or initiate rollbacks, and onCompletion for final cleanup and archiving. Think of Slack's file uploads. A success callback triggers virus scanning and preview generation, while a failure callback alerts security. These hooks make your system highly reactive and integrated. In the real world, things fail. Networks glitch, services overload, and bugs happen. But a production-ready task orchestration system must have robust error recovery. Simple retry isn't often enough. Our recovery system implements multiple sophisticated strategies. For transient issues like a momentary network hiccup, we use immediate retry. The task attempts to run again instantly, usually a few times. If a service is overloaded, repeatedly retrying instantly just makes things worse. That's where exponential backoff comes in. It waits for progressively longer periods between retries, maybe 2 seconds, then 4, then 8, giving the struggling service time to recover. For more systemic failures, where a service is clearly down or unhealthy, we employ a circuit breaker. Much like an electrical circuit breaker, it trips and prevents further attempts to call the failing service, redirecting requests or failing fast until the service's health check passes again. This prevents cascade failures throughout your system. Finally, for tasks that consistently fail due to permanent, non-recoverable errors, we use a dead letter queue, or DLQ. This preserves the failed task for manual investigation or reprocessing, ensuring no data is lost and providing valuable insight into recurring issues. These layers of defense are crucial for building truly resilient systems. We've covered a lot of ground today, transforming our understanding of simple task queues into a comprehensive view of production-ready task orchestration. Let's quickly recap our learning objectives. You should now be able to, first, understand the principles of workflow orchestration by modeling task dependencies as directed acyclic graphs and how topological sorting dictates execution order. Second, you learn to implement conditional execution using predicate functions, enabling smart, adaptive workflows. We also explored event-driven callbacks with on-start, on-success, on-failure, and on-completion hooks for seamless integration and responsiveness. Third, we delved into designing robust error recovery strategies, moving beyond simple retries to implement immediate retry, exponential backoff, circuit breakers, and dead letter queues to build highly resilient systems. Finally, you now appreciate how to integrate task orchestration into your broader infrastructure management, turning it into the backbone for scalable and reliable distributed systems. To assess your understanding, here's a quick self-assessment. How would you design a workflow for a continuous integration and continuous deployment, or CI/CD pipeline, incorporating dependencies, conditional steps, and error handling? In our next lesson, we'll explore how to take these orchestration patterns and apply them to specific use cases, diving deeper into real-world implementations and optimization techniques. Great work today!